Hello and welcome to Calculus tutorial. With this video we're going to take a look at how we can find the derivatives of more complicated trig functions. We have done sine and cosine so far, the first week of school. So we know the derivative of sine is cosine, and we know the derivative of cosine is negative sine. And what we're going to do is we're going to use those two facts along with the quotient rule to find the derivatives of these four trig functions, the other four: tangent, cotangent, secant, and cosecant. So we're sort of going to put those two together to find four more derivatives that we can do. So let's start by using the quotient rule to find the derivative of tangent. So how am I going to find the derivative of tangent? Well, the way it looks right now, we can't do it. Instead, we have to go back to your trig class and remember, what is another way of writing tangent? It is sine of x over cosine of x. So we don't know what the derivative of tangent is, but I do know what the derivative of these two are. And so I'm going to rewrite this derivative. Now I'm not taking a derivative yet, so I have to keep the derivative symbol. We are still going to take the derivative, but instead of tangent, we're going to have sine of x over cosine of x. Now we simply have to use the quotient rule to find this derivative. It's not going to be pleasant, but at least we can do this. So the derivative of the first will be cosine of x times the second, which is again cosine of x, minus the derivative of the second, which is negative sine of x, times the first, which is another sine of x, all divided by the bottom squared. So cosine squared x. And of course, the two negatives make positive there. So this derivative does not look very good. But we can simplify it. Here, cosine times cosine is cosine squared, plus sine times sine, sine squared. And on the bottom, cosine squared. It's already looking better. But we can keep going. Hopefully the top looks familiar. Now I must say, no, you cannot cross out the cosine squareds. The order of operations is not in your favor there. With this addition, we cannot do any canceling. So do not do that. We have to keep working on simplifying the top. So I'm hoping cosine squared plus sine squared rings a bell to you. You memorized this last year. That is a trig identity, and that is simply equal to 1. Sine squared, you probably did the other way around. Sine squared plus cosine squared is equal to 1. So we have 1 on the top and cosine squared x on the bottom. That made things much simpler, but we can continue to rewrite that. 1 over cosine squared. I'll even write this long ways. That is, let me come over here. 1 over cosine times another 1 over cosine. The squared simply means you write it twice. And 1 over cosine, hopefully that looks familiar as well. That is secant. So we have a secant times another secant, which is 2 secants. Well, secant times secant, which is secant squared x. And we have our derivative. So the derivative with respect to x of tangent is equal to secant squared x. Now, here's the thing. You don't ever want to do that again. Instead, you want to memorize this. So if you ever have to take the derivative of tangent again, you do not have to do the quotient rule. That takes way too long. We've done it once. We should never do it again. You just need to memorize the derivative of tangent is secant squared. Now, what about all the others? We did one. There are 3 more. We did tangent. There is still cotangent, secant, and cosecant. Now, I'm not going to do all of those for you, but I can at least get you started. So cotangent, if we remember, what is the definition of cotangent? Well, that is the reciprocal of tangent. So if tangent is sine over cosine, the reciprocal of sine over cosine will be cosine over sine. So if you want to do this derivative, you are going to take the derivative with respect to x of cosine over sine. And you will use the quotient rule, and you will get your answer. And again, you'll only ever want to do that quotient rule once. You won't want to do it again. For this one, a little easier here. Secant, what is the definition of secant? That is simply 1 over cosine. So again, you have a quotient. You can use the quotient rule. The top is 1, the bottom is cosine, and you will be able to find your answer. And then cosecant, so the definition of cosecant is 1 over sine, and again you use the quotient rule to figure that out. Again, you only want to do that once. You should never have to do it again. And so what do we get here? Well, for cotangent, we get negative cosecant squared. And for secant, you get secant x times tangent x. Let me put parentheses around my x. It makes it look a little bit nicer, I think. And then the last one, cosecant, is negative cosecant times cotangent. So you should be able to check all those answers with the quotient rule, but that is what you get. All right. So now that we have these 4 new derivatives, we should be able to use them. So here is a function, y equals 5x squared times tangent x. What is the derivative y prime? Well, as you can see, I have one function here and one function here. They are multiplying. This is going to be a product rule. So the derivative of the first times the second plus the derivative of the second times the first. So we get 10x, that's the derivative of the first, times the second, plus the derivative of the second. So I want to take the derivative of tangent. All right, I know what that is now. Secant squared x. I don't need the quotient rule. I now have that memorized. Times the first, 5x squared. All right, now that is technically the derivative, but we can clean this up just a little bit. What do these two have in common? Here we have a 10x, and here we have a 5x squared. So it looks like we have 5x in common. So I'm going to pull out a 5x. There's a 2 left over times tangent plus, and if I pull out a 5x, there's just an x left over with secant squared x. Alright, there is our derivative. Again, it's not a very nice looking derivative. It doesn't simplify down to something small, but that is the slope function. Alright, one more for us to try here. So not just a simple derivative. Find the tangent line to the graph of secant x when x is equal to pi. So I want the tangent line this time. So remember, for a tangent line you need two things. You need a slope and you need a point. So let's start with the slope. Of course, another word for slope is derivative. So we need to find the derivative, y prime. Well, what is the derivative of secant? We now have that memorized. Secant x times tangent x. Of course, we don't want just the slope function. We want the slope when x is equal to pi. So we are going to plug in pi for x. Just use function notation so we can see what we're doing. So we have secant of pi times the tangent of pi. Alright, so what are those? What is the secant of pi and what is the tangent of pi? So remember, secant is 1 over cosine, and tangent is sine over cosine. So we plug pi into all of those. Remember, you've got your unit circle over here. Pi is right here, and cosine is the x value, which is -1, and sine is the y value, which is 0. So we have 1 over -1 times, and over here we have 0 over -1, which that works out nicely because 0 divided by anything times anything is 0. So y prime at pi is equal to 0. So our slope is 0. So when we do we'll do slope-intercept form this time. Y equals mx plus b. We have y is equal to 0x plus b. The slope is 0. So now we need the b value. Remember, to find the b value, you have to plug in your x, which of course won't matter, and then plug in your y value. So I never told you the y value. Remember, the two things you need are the slope, and I guess I'll put it down here, and the point. We haven't talked about the point yet. The point is the x value is pi, but what is the y value? I never told you what the y value was. So you have to take x, plug it into the equation to find the y value. What point are we actually looking at? So if we plug in x, or pi in for x, you get secant of pi, which is 1 over the cosine of pi. And cosine of pi is -1, so this whole thing becomes -1. So sometimes you have to find that y value on your own. So If we plug in pi for x, that of course does nothing because we're just multiplying by 0. But negative 1 goes in for y, and so we get negative 1 is equal to b. And so our final equation is y is equal to 0 times x, which is 0, minus 1. So it's a horizontal line, y equals negative 1, because of the mx here crossed out because of our 0 slope. All right, hopefully that helps you with some trig derivatives. Those are 4 new derivatives that you will eventually have to have memorized. We will continue working at that. Good luck to you.